Okay, so what we're looking at here is just a wee example of how to sketch what we call a quadratic graph. Okay, so a quadratic is anything, you've seen them before, anything where an x squared is the biggest term we have. So there is an x squared, but there's no x cubed or to the power 4, power 5, power 6, etc. X squared is the biggest, what we call the largest order of x in that term. Okay, so what we're going to do with this is exactly the same as you've done before with straight lines. Okay, we're going to take a set of x values, okay, and we're going to figure out, right, well, when x is this, what must y be? We're going to get matching x and y values. We can turn each of those pairs of numbers into a coordinate point and then just sketch them on a set of axes. Okay, so for each question you're going to do today, you're going to see something like this after it as well. Okay, so what we're told here is sketch y equals x squared plus 4x plus 3 when negative 4 is less than or equal to x, which is less than or equal to 0. This is basically telling you what your numbers are for x. Okay, so we want the x to be all the numbers from negative 4 up to 0. So negative 4, negative 3, negative 2, negative 1, 0. Okay, so whichever numbers you're given here on the end of your question, that tells you, right, these are the numbers to do on your table. Okay, so like we did before, we're going to have our x and our y. Okay, and x is going to be negative 4, negative 3, negative 2, negative 1, 0. Y we're going to figure out just now. Okay, so what we're going to do is just take each of these x numbers one at a time and we're going to substitute them in to this function here. Okay, so when x equals negative 4, y equals negative 4 squared plus 4 times negative 4 plus 3. So all we've done here is take negative 4 and we've changed the x in this function to a negative 4. And we can now calculate that. Negative 4 squared is 16. 4 times negative 4 is minus 16. And then plus 3. 16 take away 16 is 0. Plus 3 is 3. So that y value there must be 3. Okay, similarly, x equals negative 3. So we're going to change the x in our function into a negative 3. So we've now got negative 3 squared, which is 9. 4 times negative 3, which is negative 12. And then our plus 3 on the end. Tidy that up. 9 minus 12 is minus 3. Plus 3 is 0. Okay. X equals negative 2. Again, we're just going to take that negative 2 and substitute it into where the x's are in that original problem. So this one gives us 4 minus 8 plus 3, which is negative 1. Okay. Bear in mind, obviously, I'm doing these quite quickly just to try and let you get on with some work. Don't worry about how long this takes you. Okay. Today is really just about getting an idea of what these graphs look like, so that when I go on to future lessons and start talking about roots and turning point and all these things that we've not done yet, you won't be totally lost. You'll have an idea of what the graph looks like. You'll have an idea of what all these things are that I'm pointing at. Okay. X equals negative 1, so again, let's just pop that in there. Negative 1 squared is 1, minus 4, plus 3, that comes out to being 0. And when x is 0, y equals 0 squared plus 4 times 0 plus 3. Nice and easy, that one. That just comes out at 3. Okay, so what we now have are 5 pairs of numbers, x and y for each one. Okay, each of these is a coordinate point. Okay, so what we're going to do is make a graph that goes through the points negative 4, 3, negative 3, 0, negative 2, negative 1, negative 1, 0, and 0, 3. Okay, and obviously if you're doing this in your jotter, you've got squares for this. Okay, just for today's lesson, use those squares to keep you right. Obviously I'm on blank paper, so I'm going to have to do a wee bit of guessing, but use the squares for negative 4, 3, count out 4 boxes, 3 boxes. Okay, so we need to make sure that our x-axis goes as far out as negative 4, and our y goes from negative 1 up to 3. Okay, so something like that should do the job, okay? And I'm just going to fill in, bear in mind, for my one, these will be wee estimates. As I say, you've got squared paper, use it, keep it exact, okay? Okay, it's a bit wonky, but it'll do for now, okay? So plotting our points, -4, 3, so that's going to be round about here. -3, 0, it's going to be right on that line. -2, -1 is going to be down here. -1, 0 again on that line. 0, 3 on that line. And all we're going to do, you can see there that these are coming down in a sort of a U shape, okay? Absolutely spot on, that's exactly what we're looking for, okay? So we're going to connect them up, try and keep it a nice neat curve, not straight lines if you can, okay? And it should just extend a little bit beyond your outside points, just a wee bit, just to show that the curve does continue. It doesn't just stop dead at those points. It does continue on a wee bit, but we don't have to worry about that just now, okay? This shape here, this curve, is called a parabola, okay? And you're going to be seeing an awful lot of them over the next 2 or 3 lessons. Okay, so that is the name of the shape. It is a parabola, P-A-R-A-B-O-L-A. They can be U-shaped, sometimes they'll be upside down, okay? Sometimes, but that as we've seen, sometimes they'll be like that. For the time being, you do not have to worry about which is which. As long as you end up with this shape, if it's the other way up, that's absolutely fine. Okay, so I've shown you one example. I'm not going to spend ages running you through essentially the same question, 3 or 4 times. The key things for what you're doing today is that these numbers here in the question tell you where your X numbers are going to be. So if that said -3 and 2, your numbers would be -3, -2, -1, 0, 1, 2. Okay, so all the numbers between those two, that is telling you this list for your X's, okay? Once you've done that, take your time. Don't worry about doing these quickly, okay? Figure out what the matching Y value is for each one, turn them into coordinate points, and then just get a wee sketch down, okay? Remembering, as I've just spotted is missing from mine, your X and your Y on your axes, okay? And that's what a parabola is. As I say, the next wee while, we're going to look at properties of these. How do we figure them out if we don't have all the information? What do we do? How can we use them to calculate things? But for today, we just want you to become comfortable with this shape of graph, okay? And as I say, either like this or the upside down ones as well. Just getting used to the idea, knowing what they look like. That's all we're needing from today, okay? As usual, let me know if you need any help.